Combustion analysis is a form of analysis that will be used to determine the amount of carbon and hydrogen present in a sample. So an organic sample is going to be, you saw on a previous slide, that organic compounds contain carbon bound to nonmetals such as hydrogen, nitrogen, oxygen, sulfur, any of the nonmetals. So it's covalent compounds that are containing carbon, okay? If the compound only contains carbon-hydrogen bonds, it is called a hydrocarbon. But anytime that there is hydrocarbons that contain other nonmetals, this is called a functionalized hydrocarbon, which you will learn a lot more of once you get to organic chemistry. So for now, we're just recognizing that hydrocarbons is only carbon and hydrogen. Functionalized hydrocarbons have other nonmetals present in addition to carbon and hydrogen that gives you a group of atoms that's called a functional group. It gives the compound a particular function and reacts a certain way. You'll learn all that in organic chemistry. So now, the problem that we're going to practice is going to be taking some experimental data of a sample and trying to determine what the molecular formula of that substance is based on the data that is obtained through combustion. So what combustion is the reaction with oxygen and heat in order to form carbon dioxide and water. So if we collect the amount of carbon dioxide and water in these absorbents, there's water absorber and a carbon dioxide absorber, we can measure the exact amount that was produced by the combustion of a sample. So when you progress to the next slide, you most likely didn't see anything here, but what had happened is that a file had downloaded. So I have a file here that goes through the steps that are required for completing a problem for determining molecular formula from combustion analysis. So the steps here are all written out step by step of what I'm going to do as we do this practice problem on the next slide. So you will be able to follow along with me as I do the problem. It is a lengthy calculation, so just take notes as I do the calculation. And then after you take the notes from my calculation on the board, then go back to reanalyze what the steps were according to what is on this PDF, so that you can start to get into the thought process that is required for these types of problems, because it is fairly involved, but there, once you see how it is applied and then see how these steps are followed, this can be then applied to any of the combustion analysis problems, okay? So in combustion analysis, you will have the combustion of a hydrocarbon or a functionalized hydrocarbon. If it's a functionalized hydrocarbon, we'll need to figure out how much of that other element is present. So of course, I'm getting too much into details right now. Let's first just start working on a calculation, and then it will kind of all start to come into play and come into become more understandable. So when you progress to your next slide here, you're going to see this example. So this example says a dry cleaning solvent, which has a molar mass. So this symbol represents molar mass. Molar mass is equal to 146.99 grams per mole, and it contains carbon, hydrogen, and chlorine. Therefore, we would call this a functionalized hydrocarbon. It is suspected to be a cancer-causing agent. When 0.25 gram sample of the solvent was studied by combustion analysis, 0.45 grams of carbon dioxide and 0.0617 grams of water is formed. You are then asked to find the molecular formula from the data given. So I'm going to conduct this calculation on the board here, and you're going to see that it's going to be following these steps that were provided on the PDF. So after completion of my video, go back to the PDF and make sure that you understand the steps that I had taken, because you will then be required to apply it to an example in a coming activity. Okay, so on the board here, I wrote out all the given information from the problem. So we know that we have a sample that is 0.25 grams of the compound that contains carbon, hydrogen, and chlorine. When it underwent combustion, it forms 0.451 grams of carbon dioxide and 0.0617 grams of water. So these amounts of carbon dioxide and water can give you information to determine the amount of carbon and the amount of hydrogen that is in that sample that underwent combustion. Okay, so we're going to use this information in order to figure out the amount of carbon and hydrogen in the compound, and then from the total amount, the total grams of the sample, we can find the grams of chlorine. Okay, so let's take this one step at a time, because then once we have all that, we then have to determine the empirical formula and molecular formula. Okay, so we'll start with 0.451 grams of carbon dioxide. Okay. So please be taking notes as I'm writing this on my board, because I will most likely run out of space and need to erase. So, so just be taking notes as I am writing so that you can have all of the calculations all on one page for yourself to refer to. Okay. So we're going to start with taking our amount of carbon dioxide that was formed, and we're going to convert this into moles. Okay. Because from moles of carbon dioxide, we can find out the amount of carbon that was formed. Okay, so we're going to take the molar mass of carbon dioxide. So when we add together 1 carbon and 2 oxygens, we add the masses together to get the molar mass to be 44.01 grams of carbon dioxide in 1 mole of carbon dioxide. Okay. Once we've determined the moles of carbon dioxide in the given amount, we can figure out how much of that amount is carbon. So how many moles of carbon is within carbon dioxide? 1 mole of carbon is in 1 mole of carbon dioxide, according to what we learned about the subscripts. Okay, so since there's only 1 carbon, there is 1 mole of carbon in 1 mole of carbon dioxide. Okay, so this is going to give us the amount of carbon in moles. Okay, so I'm going to solve for the moles first and then convert it to grams. And you'll see why later on, why I did moles first and then converted to grams. Okay, so because we're going to need those moles later on for the empirical formula. So what I see here is 0.0102 moles of carbon when you go through your calculation here. Dividing 0.451 by 44.01, and then of course this is 1 to 1, you would just get 0.0102 moles of carbon. Now we're going to do the same thing to determine the amount of hydrogen. but this time we're going to use the amount of water. So how much hydrogen is in that amount of water? So that's going to be 0.0617 grams of water. First, we convert the grams into moles using the molar mass of water. This is going downhill. Okay. 18.02 grams of water per 1 mole of water. Now, how many moles of hydrogen is in 1 mole of water? There are 2 hydrogens in water. That means that there are 2 moles of hydrogen per 1 mole of water. This will now give you the amount of moles of hydrogen in our compound. And what I get in my calculation is 0.00685 moles of hydrogen. Recognize that I am following the significant figure rules here. There were 3 significant figures here. Remember, this 0 is a leading 0, not significant. 1, 2, 3 significant figures here. 1, 2, 3 significant figures here. 1, 2, 3 significant figures here. These are leading zeros. 1, 2, 3 significant figures here. These are leading zeros. I know I just repeated myself 4 times or however many times, but I just wanted to make sure that you're recognizing how I am following the significant figure rules. Okay, so now we've just determined the amount of carbon and the amount of hydrogen in our compound in terms of moles. Now, remember, our compound also contains chlorine, and we know the total mass of the sample. So if we can figure out the amount of grams of carbon and grams of hydrogen, then we can subtract it from the total grams of the sample to give us the grams of chlorine. Oh, my dog just walked in. So here's my baby. Here's my puppy. Yeah. You startled me. Yeah, good boy. All right, go see daddy. Come on. Come on. Go ahead. Ay. Okay. All right, so now we're looking to determine the grams of chlorine, okay? So to determine the grams of chlorine, we first need the grams of carbon and hydrogen to subtract from the total grams of the sample. So now we're going to take the moles of carbon and the moles of hydrogen and convert them each to grams. Okay, so I'm going to start down here, 0.0102 moles of carbon. If you have more space on your paper, you can just continue it forward that way. But of course, I have limited space here. So okay, so now 0.0102 moles of carbon can be converted to grams of carbon using the molar mass of carbon from the periodic table. 12.01 grams of carbon per 1 mole of carbon. So when we multiply here, what we will get is 0.123 grams of carbon. Now for hydrogen, we're going to take 0.00685 moles of hydrogen and convert this to grams. 1.01 grams of hydrogen is in 1 mole. of hydrogen. Cancel units here. And then now we're going to solve for the grams of hydrogen. By multiplying by 1.01, you get 0.00692 grams of hydrogen. Okay, so now if we know that the sample contains 0.123 grams of carbon, 0.00692 grams of hydrogen, and the total is 0.250 grams, by subtraction, we'll be able to find the mass of chlorine that's in the compound. So let's do our subtraction. 0.250 grams of your sample minus 0.123 grams of your carbon minus 0.00692 grams of the hydrogen. When we subtract all this, we're going to obtain grams of the chlorine, because this is of the total. And if it's made up of carbon, hydrogen, and chlorine, then subtracting the masses will give us what chlorine is. So when we subtract and apply the significant figure rules for subtraction, we keep the least number of decimal places. So the least number of decimal places is going to be 3 decimal places, because here it goes to 1, 2, 3, 4, 5. This is 3, this is 3. So we're going to round our final answer to 3 decimal places. And what I obtained for that is 0.120 grams of chlorine. Okay, so as you can see, I ran out of space. So the next step that we're going to do, now that we know the mass of all the elements that make up the compound, now we're going to apply the steps to empirical formula and then determine the molecular formula from our molar mass that's given. Okay, so now I'm going to clear my whiteboard here. So I hope that you've been able to write this down along with me. But of course, you have this here right now to look at. And then, but I'm going to erase this for now. And now we're going to get started with the 3 masses, carbon, hydrogen, and chlorine. And we already have the moles here. So the first thing we need to do is find then the moles of chlorine. Okay. Okay. So we just determined that the compound contains 0.120 grams of chlorine. Okay. Now remember, the step for empirical formula is to take each mass of the elements in the compound and convert them to moles. So we need to change the mass of the chlorine into moles. The molar mass of chlorine is 35.45 grams of chlorine per 1 mole of chlorine. This is going to give us 0.00339 moles of chlorine. And then from before, we had determined that there was 0.0102 moles of carbon. And we also had determined that we had 0.00685 moles of hydrogen. Okay. So now we need to look at these amounts of each element and figure out which is the smallest amount and divide each one by that smallest amount. So the smallest amount here is going to be the amount of chlorine. So we're going to divide each one of these by 0.00339. 0.00339. I'm running out of space, sorry. Should have moved it over. Divide this by 0.00339. So when we divide them each by the smallest amount, what we end up getting is 3 moles of carbon to 2 moles of hydrogen to 1 mole of chlorine. So now this is going to give you your whole number ratio for the elements that make up the compound in the empirical formula. So this is the empirical formula is equal to C3H2Cl. Okay. So there's our empirical formula. To find the molecular formula, we need to find that whole number factor that would be multiplied by the formula by taking the true molar mass divided by the empirical formula mass. Okay, so let's calculate the empirical formula mass. 3 carbons, 2 hydrogens, 1 chlorine. So that's going to be 3 times 12.01 grams per mole. 2 times 1.01 grams per mole, and then 35.45 grams per mole. Add these together, and we get the molar mass of the empirical formula to be 73.5. 73.50 grams per mole. Okay, so that's our empirical formula mass. The molar mass that was given is 146.99. $146.99 grams per mole divided by 73.50 grams per mole is going to give you the whole number factor to be equal to 2. Therefore, we multiply the empirical formula by 2, each subscript by 2, to give us our molecular formula. So our molecular formula is equal to C6H4Cl2. And that completes the steps. So now that you've seen all the calculations done following the steps, I suggest you go back to that PDF file that I have created that includes the steps of the proper thought process, and then be sure that you get a solid understanding of how to apply those steps to the problem. Okay, so refer back to that PDF, kind of follow along with the steps that we just did with the calculations, and make sure that you are recognizing how those steps were applied. Okay, and then give it a try on the coming problem to apply those steps. Okay, so eventually you're not always going to have those steps to refer to. Eventually, with enough practice, you'll be able to have that thought process in mind of the necessary steps to get you from point A to point B, okay, to get you from the problem to the answer.